Working in the North Sea, I can remember 2 occasions when we had problems that were caused by the misuse of slips. On the first occasion, we were leaving the slips in the hole while the driller was stripping pipe through instead of actually pulling them out. On the second joint of pipe, coming up through the rotary table, had one of these rubber protectors on the pipe. It's hit the bottom of the slips, actually ejected them out of the rotary table, and they fell over on one of the fellow's feet that was standing there waiting to put the tongs on. It ended up breaking, I think, 2 bones in his instep, and of course he lost a lot of time from the job because of this accident, and of course it caused us a bit of difficulty. On the second occasion, we were using a set of slips where the inserts had gotten too dull, and we had set the slips on the pipe, removed the elevator, and just about that time the slips released the pipe. The tool joint hit the top of the slips, bounced them out just enough to allow the tool joint to fall through the rotary, and we ended up losing all the pipe down the hole.
The situation that Dan described happened because someone was trying to save some time. Now ask yourself, was the time saved worth it? You sure don't want anything like that to happen to you. That's why it's important to know the proper way to use your slips. That's what we're going to show you in this program. How to set the slips, how to pull the slips, as well as inspection and maintenance of your slips as it applies to both pipe and collar slips. You'll see what'll happen because of poor maintenance and operation. And finally, some do's and don'ts. Slips are like everything else. They require constant care and maintenance for safe and proper operation. Remember the old adage, if you take care of your tools, they'll take care of you. By watching this program, you'll learn just about everything you need to know about pipe and collar slips. In the first section of this program, we'll cover drill pipe slips. There are 2 basic types. The power slip, which can be pneumatic or hydraulic, and the hand slip, which is used exclusively on Sedco rigs. On your rig, you're probably using slips manufactured by Bash Ross, Varco, or Mission. They're all 3-piece segmented unitized slips. The main difference is the shape and length of the gripping element and the length of the supporting members. These differences relate to the holding power of the slips. First, let's talk about why we need slips. They're used to hold a section of the drill string for support while other members are being removed or added. The slip has a circular gripping section and a wedge-shaped back. As weight is applied to the slips, they seat into a tapered bowl in the master bushing. The taper of the bowl forces the grips into full-length contact with the pipe so that support is provided without crushing the pipe. How much pipe the slips can hold depends upon the length and condition of the gripping elements and also the fit between the back of the slip with the bowl in the rotary table. Let's go over the parts on a drill pipe slip. There are 3 slip segments, left, center, and right. Each has a handle that attaches with pins, washers, and cotter pins. The 3 segments are jointed together with hinge pins. Each slip segment has many gripping elements called dies or dogs with keepers which keep the dies in place. A set of 5.5-inch drill pipe slips weigh in at 225 pounds. A change in the thickness of the gripping dies will make one slip body accommodate several sizes of drill pipe. As with any other tool used on the rig, you can expect your slips to wear. There are 3 basic areas of wear on the slip. The first is loss of gripping profile. This happens because the teeth fill up with mud and grease. This is a day-to-day occurrence, and all you have to do to clean the teeth is use a wire brush, which will have to be done every time the slips are used. Also, as you clean the slips, you should check to see if any of the dies have worn excessively or broken. When this happens, you must replace all the dies in that segment. Don't try to sharpen the dies or mix old and new dies in the same segment. This is an example of another type of wear you can have on your slips. As you can see, the hinge pin is worn and bent. This condition causes the slip to close unevenly. This happens due to normal wear and tear. If the problem is excessive, you must replace the slip. The last area of wear is when you have loss of contact between the outside surfaces of the slip and the bowl face. This condition is a result of a change in the contour of the slips or the bowl. It's also due to normal wear and will cause your slips to set unevenly in the bowl. The slip can wear in any of the three places we described. When this wear occurs, you'll notice that the slips won't hold the pipe, and you'll have severe gouges where the top dies meet the pipe. You also won't have marks indicating the full tooth segment is biting. If you have a rash of drill pipe failures in the slip area, you know you have a problem with your slips. Rarely are failures limited just to the slips, though, because wear in the bowl can also contribute to drill pipe failure. If you have reason to believe that something is wrong with your slips, you should go ahead and check them out. The first thing you should do is clean them up with a wire brush. Be sure to get all the mud and grease off the teeth. Next, check for uniform tooth wear, and if the teeth are uneven, change the dies. Have your driller verify the fact that you need new dies, and when you do, be sure to replace them with identical replacements. We'll show you how to do this later in the program. Now you need to go ahead and make some tests to isolate the problem with your slips, and at the same time, you'll find out if the problem is in your master bushing. The first test you need to make is a paper test. In order for the test to be effective, you must have a minimum load of 100,000 pounds. First of all, clean your slips with a wire brush and wipe the outside surfaces clean. Find a section of pipe that's free of die marks. Next, take some waterproof paper, or if you can't find that, any kind of heavy paper, and wrap it around the cleaned section of the pipe. Tape the paper at the top and bottom. Next, carefully place the slips around the wrapped section of pipe and lower them into the bowl with normal setting speed. Apply full string weight to the slips. Holding the slip handles together, slowly raise the pipe and remove the slips. Be careful not to tear the paper. You'll notice that the dies left marks on the paper. These marks will tell you what condition your slips are in. Now, carefully remove the paper and lay it flat. If you have full-length die contact, this indicates your master bushing and slips are good. Even though you might have full-length die contact, you may not have uniform die contact. Evidence of this would be if you can see an ununiform pattern on your test paper. This indicates you might have to replace some dies. We'll show you how to do this later in the program. Now, looking again at your test paper, if you only see die contact on the top section, this tells you that you have a problem with your master bushing or slips. Now you know you have a problem. If you have a new or like new set of slips, you can isolate the problem by repeating the procedure with the new slips. If the new test shows insert contact on the top section, just like your other set of slips did, you know your problem is in the master bushing, which will have to be repaired or replaced. If the new slip shows full insert contact, your problem is with your old set of slips. They'll have to be replaced. Be sure to tag the slips to be replaced so that someone else doesn't come along and think they're okay. There's one more test you can do to further confirm your problem. You'll need to take a ruler or straight edge and put it up against the outside of the slip surface. Now look for full-length contact. If you have clearance between the slips and the straight edge, it confirms that the slips are faulty. You should repeat this test on all 3 slip segments. A problem in any segment will mean you have to replace the slip. The same test can be done on the master bushing. Except this time, put your straight edge up against the taper of the bowl and look for clearance between the straight edge and the bowl.
Full contact there.
Do this at least 4 times, and if you find a place with clearance, mark it and have your tool pusher check it out. It's important that all problems with the slips and the bushing be reported to the tool pusher and recorded in the IADC drilling report. As you can see, you can have contact problems in both the slips and the bowl. A problem in one means you should check the other one out. Now we'll show you what can happen to the pipe if you have contact problems. If you have a worn master bushing with new slips, your slips can sink into the bowl and lose full contact. This can result in bottlenecking your pipe. The reason the pipe bottlenecks is because the pipe is only being supported at the top of the slips. Here's an example of what can happen when the pipe is bottlenecked. The pipe can develop gouges or cuts, which give you a starting point for a fatigue crack. This will speed up the corrosion process, which may eventually cause the pipe to develop a washout. As you can see, the same problems can happen with worn slips and new bushings. Due to wear, the slips don't have full contact with the bowl face. Again, this can result in bottlenecking and gouging on the pipe. Here's what happens when you have a size mismatch between your pipe and slip. As you can see, this slip has cracked. That makes it junk. If the pipe is larger than the slips, you'll crack the segments on the slips because of a lack of proper contact. You can't use 5-inch DP with 4.5-inch slips. Our 2 friends here will show you what can happen if you let wear and mismatch problems go unattended. Dropping the pipe happens more often than you might think. You sure don't want it to happen to you. Earlier, we mentioned that you might have to change some dies. This is the way that it's done.
Changing out your dies and your slips. Take an Allen wrench, turn out your Allen head screw. Right now I'm hammering out the dies, getting ready to insert the new ones. Sometimes they get stuck in the bottom because they ain't cleaned out right before they're put in. Okay, then after you get all your dies out, you clean it up good with a wire brush. And then you put some oil in it so that next time when you get ready to take them out, they'll slide out a little easier. Now I'm going to insert the new dies, no matter which side you put them in, because it's all made the same on both sides. After you get your dies inserted, you put your Allen head screw back in it to hold them in place so they won't come out when you're tripping pipe or making a connection or anything like that. That's all it takes to change your dies and your slips. Sometimes they come out a little bit harder, sometimes they come out easier. It depends on how you clean them up. The most important thing though is your goggles when you're removing them, because they'll blind you. Safety first out here.
Now that you know how to maintain your slips, we'll show you some do's and don'ts of proper operation. The trick is to let the drill pipe do most of the work for you by lifting the slips. The following do's and don'ts should help you. Do make sure you clean your dies on every trip with a wire brush, as well as greasing the back of the slips and the bowl face. Do remove your hands as soon as you place the slips. Beware of clutch-footed drillers. Do let the pipes pull the slips for you. That way you're not doing most of the work. Always advise your driller if you think you have a problem.
Hey, driller! Yeah, man, what's the problem? I got a problem. What's your problem? My girlfriend's getting tired of these late shifts. Go ahead, you say.
We mean with the slips, dummy. Don't let the slips ride the pipe. They could fall and hurt you. Don't set the slips with your foot, because the pipe could still be moving. Don't substitute the slips for the brake. You'll damage the pipe. Don't sharpen dies. It'll scar the pipe. Don't mix old and new dies on a segment. It'll make for an uneven gripping surface. Don't set the slips on the tool joint. You won't be able to set the tongs. Don't set your tool joint too high. You'll bend the pipe. Don't drop the pipe. Well, that's about it on the drill pipe slips. Now we'll briefly go over the several types of drill collar slips found on most rigs. Drill collar slips are used to hold the drill collar as you remove or add sections. A zip collar is a type of collar that has recesses or shoulders built into it, which hold the slip. A slick collar, which has no recesses, requires both a drill collar slip and a backup safety clamp. This is a typical drill collar slip. As you can see, you have multiple segments which are identical. To accommodate various size collars, all you have to do is add more segments. The individual segments are coupled with hinge pins. The handles are attached with pins to the middle and end segments. Each segment has a set of dies. The dies can have one of two types of contact surfaces, buttons or teeth. Buttons are usually used on collars because they're less likely to chip and fracture since they don't have any exposed sharp edges. Daily maintenance is as important to drill collar slips as it is to drill pipe slips. Be sure you check and clean your gripping surfaces. In case of question or problems, see your driller. This backup holding device is for a slick collar. It's called a safety clamp. As shown here, it's a lightweight, short-tooth clamp with an adjusting bolt. To accommodate different size collars, you simply add or remove teeth segments. The trick to using the clamp is to take a hammer and tap the dies while you're tightening the clamp to ensure all teeth make contact. Well, that about covers what you need to know about drill pipe slips and drill collar slips. You might want to review the parts of this program that go over the various tests so that you become more familiar with them. Remember, a well-maintained slip is your key to safe and productive drilling.